Agenda. In this short video, I'll discuss the following topics. Topic number 1, how to test independence of two datasets. A. Definition. B. Formulas. C. Decision rule. Topic number 2, one example using Excel.
Shutterstock Music.
Let's do one in-class exercise. Okay, if you are taking my course right now, you type .ice, in-class exercise. Okay, so let's look at 51. Okay, so we enter 51. A sample of 200 beers drinkers is taken. Our hypothesis beer preference is independent of gender. Alpha equals 5%, and degree of freedom is n-1 and times n-1. So n is, we have 3 different types, light, regular, and dark. So n equals 3, we have male and female. There's 4 methods to get the data. Okay, I'm going to use method 1. Okay, the first one is, so type .a. So .a actually is searching data ID. Okay, so I will enter keywords beer. So data ID is 189. Is beer preference. Okay, then we type .b 189. Then we launch Excel and paste it there. Okay. So we launch Excel and paste. Okay. The first column is ID. Okay, so then we ask preference, regular, light, regular. The first observation is male, the second one is female. Okay. So according to the textbook, so we are going to generate this kind 3 by 2. So 1, 2, 3. There are 3 rows and 2 columns. So 2 columns. Okay. And a better way to do it is using so-called pivot table. Okay. So let's highlight those columns and click Insert. On top left is called Pivot Table. Okay, click Pivot Table, and we highlight these 2 columns already, and we can go to a new worksheet or spreadsheet. Okay, so this is a black one. Okay, and we have the preference. Now we have the gender. Okay, so let's grab this one to our row. Okay, so this is our rows, and dark, light, regular. Okay, so let's grab this one to our row again. So dark, we have female, male, and light, we have male and female, and then we drag the preference, and we are going to use count. Okay, so the count of preference. Okay, so this is male is 8, and female is 8, male is 25, total is 33. Okay, so this is light, and so let's copy this one. We copy as a value. Okay, so we go back to our original sheet. Okay, so let's go back to our original sheet. Okay, so let's paste it somewhere. We paste as value. Okay. I'm going to make a little bit. Okay. So according to this one, so we can light with light and regular, and we can dark. Dark, we have male, and also have female, and so the light we know male, so this is dark female, so this is dark female, so this is dark male, and also light female 35, so this is male light, and we have regular. Okay, regular will be male, and so this is female. Yeah, female. Okay, so 51, 39, same. 21. Regular is regular male. Okay, so regular male is 56, 25, and 8. Okay, so this area, this one is all observed. Okay, so this is all observed. Okay, so let's calculate the total. Okay, so summation. Okay, so this is summation of all male drinker. Okay, so this is summation of female. Okay, summation of female. And also, so this is total. Okay, total. So this is summation of light. Okay, so this is summation of all different categories. Okay, so male, well, 139 male and 68 female. Okay, so let's look at, so this is observed. So let's look at expected. So this is expected. So we have male, female, exact same thing. Okay, expected male and light regular. Okay, light regular. Okay, and so let's call, so this is 90. Okay, 90. So let's calculate one ratio. So this ratio is, we can use male divided by summation. Okay, summation of these two. Okay, okay. So 66% male and the difference were female. Okay, so this is male population. Okay, so this is male ratio. Okay, this is a male ratio. Okay, so the total, so suppose we have 90, right? Suppose we have 90 drinkers in terms of light. Okay, and it should have 66 of them male, and the rest should be female. Okay, so this is should be total times this ratio. Okay, so this should be 59. So I'm going to use this one as dollar sign. Okay, and I repeat. So this is a key. Okay, and so let's use another purple. Okay, so I'm going to make it bigger. Okay, so these are our observation. Okay, and 51, 39, 56, 21, 25, 8. Okay, we calculate two total male, total female. Okay, so this number divided by summation of these two will be the ratio of all the male. Okay, if male, female, they don't care about being different types, then this should be have the same. Okay, so this is 60% of 90. Okay, so this is should be equals 1 minus, so actually it's a difference, okay, times this one. So 34% times this one. Okay, I'm going to drag this down. Okay, so this is 59 and okay. Again, so this is our expected. Okay, so this is our observed 3 by 3, and this should be our expected. Okay, now we apply this formula. So we apply this formula. Okay, and so we have another 3 by 3. Okay, now we have the summation. Okay, so let's look at this 3 by 3. Okay, so let's 3 by 2. Okay, 3 by 2. So this is another one, 3 by 2. Okay. Okay. The first one is equals, okay, the first cell minus, the first cell of our observed minus the first cell of expected, and so this is power divided by expected. Okay, I repeat the concept here. Okay, so this is I equals 1, J equals 1. So this is I1, J1. So this is also I1, J1. Okay, so this is our, I'm going to use I'll still red one and red one. Okay, so this number minus this number. So we can call this error. So this is error. Okay, so error turns square and divide by expected. So we have this number. Okay, then we can simply and copy and paste. So 1, 2, 3, 3 by 3. So because we calculate the formula. Okay, so the total summation will be our chi-square. So this is our chi-square. Okay, so equal summation of these 6 numbers. Okay, 6 numbers. Okay, and we know alpha is 0.5%. Okay, so degree of freedom is, so actually we know, okay, we know it's 3 by 2. Okay, so count how many row minus 1 times count how many columns minus 1. So we should know it's 3. Okay, so 3 minus 1 equals 2, 2 minus 1 equals 1, should be 2. Okay, so let's see. So this is count. Oh, I forgot minus 1. Okay, count minus 1 times count minus 1. Yes, so it actually is 2. So this is chi-squared critical. So this is chi-squared critical value. Okay, CHISQ inverse right tail. Okay. Probability is 5% and degree of freedom is 2. Okay. Okay, so this is critical value. Okay, so this is our decision rule. Okay, our decision rule is if our calculated chi-square is higher than chi-square critical, we type reject. Otherwise, accept. Obviously, we reject. Okay, I'm going to show the formula. Okay. I'm going to show this formula. Okay, So this is calculate critical value, and this is calculate. One is calculate critical value, another is decision rule. Okay, so let's look at P versus alpha. Okay, so P value should be equals CHISQ DRST right here. So right here, and we know this is our chi-square value, and our calculated chi-square, and degree of freedom is 2. So we expect P less than 5%. So this is formula. We show the formula of our P value. Okay, make it bigger. Okay, so this is our decision. Decision rule number 2. Can we compare the P with alpha? Okay, if our P value is less than our alpha, we reject. Otherwise, we accept. Obviously, we reject. Okay, so let me summarize this exercise. Okay, and we have a data set. We have the preference, we call it preference, regular, light, dark gray, different 3 types of beer. And we have the gender. Okay, as the first step, we generate 3 by 2. 3 by 2, we can call the matrix. So this is, we generate this 3 by 2 matrix. Okay, then we calculate, this one. We generate 3 by 2 matrix. Then we calculate total male versus total female. Then we calculate ratio. Okay, our hypothesis is beer preference is independent of gender. If they are independent of gender, it should be crucially depend on this ratio. Okay, so 90. If we have 90, we generate another 3 by 2 matrix. And so this is gender independent. Okay, then we apply this formula. We calculate another 3 by 2 matrix, and we use the number count from our observed minus our expected square divided by our expected. The summation will be our chi-square value. Then we apply, then we calculate chi-square critical. So if our calculated chi-square value is higher than critical, we reject. It means they are different. Okay, they are different. And decision rule 2 is we compare the p-value with alpha. If the p-value is less than alpha, we also reject our null hypothesis. Based on the both criteria, we reject.
Shutterstock Music.